11th question. Identify the incorrect statement with regard to the thermal decomposition of the salts given below. So the salts are ammonium chloride, ammonium nitrite, ammonium nitrate, ammonium carbonate and ammonium dichromate. Right. So first let's see the decomposition reactions of these 5 salts. Ammonium chloride, when you thermal decompose it, it gives ammonia plus HCl. Then ammonium nitrite, when thermal decomposed, it gives N2 and water. Then ammonium nitrate, when thermal decomposed, it gives N2O plus 2H2O. Then ammonium carbonate, when thermal decomposed, it gives ammonia plus carbon dioxide plus H2O. Then ammonium dichromate, when thermal decomposed, it gives N2 plus Cr2O3 plus 4 water. So those are the thermal decompositions, right? Ammonium chloride, it gives ammonia and HCl upon thermal decomposition. Ammonium nitrite gives N2 plus water. Then ammonium nitrate gives N2O plus H2O. Then ammonium carbonate gives ammonia plus carbon dioxide plus H2O. Then ammonium dichromate gives N2 plus Cr2O3 plus 4 water. So these reactions you should remember, right? Now let's go to the answers. Only 2 of the salts give ammonia as a product. Let's see. So ammonium chloride, it gives ammonia as a product. Then here it does not give ammonia. Then again we can see ammonia as a product in the thermal decomposition of ammonium carbonate. Here it does not give any ammonia. So that is correct. Only 2 of the salts give ammonia as a product. That is correct. Only 2 of the salts give N2 as a product. Let's see that. Ammonium nitrate, it gives N2, right? Then again ammonium nitrate, it does not give. Again we can see nitrogen as a product in ammonium dichromate thermal decomposition. So only 2 of the salts give N2 as a product. That is correct. Then only 2 of the salts give an acidic gas as a product. Give an acidic gas. So the acidic gases are here carbon dioxide is an acidic gas. So I will use another color. Carbon dioxide here is an acidic gas and N2O is an acidic gas. So others are not acidic gases. Ammonia is a basic gas now. So only 2 of the salts give an acidic gas as a product. That is also correct. Next, only 1 of the salts gives a product that exists as a solid at room temperature. Now what is the product which exists as a solid in room temperature? Here we can't see any solids at room temperature in these reactions, right? We can't see. Yeah, here this is the solid product, Cr2O3. This is the solid product. So only 1 of the salts give a solid at room temperature. That is correct, right? Then the 5th answer is only 2 of the salts give H2 as a product. H2 is given by this one, this one, this one and this one. So 4 salts give H2O. So that is the incorrect statement. So the answer is answer 5, right? Now let's go to the 12th question. The titration given was obtained for the titration of a monobasic weak acid with sodium hydroxide. Of the statements given below, identify the incorrect statement. We have to identify the incorrect statement. So this is a titration between monobasic weak acid. Monobasic means what? It gives only one H plus. Monobasic weak acid, it gives only one H plus. So example CH3COH we can take as an example. So think of a titration of CH3COH and sodium hydroxide. As an example we can get it. Now here we are titrating the weak acid. We are titrating the weak acid with sodium hydroxide. And this is the titration curve given. Right? Now they are asking us to find the incorrect statement. At point A, the pH of the titration mixture is equal to the pKa of the weak acid. Now let's see point A. Now when we go through these 3 points, we can see this point B. This is the equivalency point. Why? Because it is in the middle of the rapid pH change. So this is the rapid pH change. Right? So in the middle you have the equivalency point. So B is the equivalency point. Equivalency point is reached when V sodium hydroxide is 25 cubic centimeters. And now here the volume is what? 12.50 cubic centimeters. Right? Now if we analyze the point A, at A what happens? Now if we take for example CH3COH plus sodium hydroxide, it gives CH3COO minus sodium plus H2O. Now if we assume same concentrations for CH3COH and sodium hydroxide, here we get the initial moles as C times 25 into 10 to the power minus 3 moles. And here C times 12.5 into 10 to the power minus 3 moles. Right? So why I take CH3COH as 25 cubic centimeters here? Because you all know that CH3COH and sodium hydroxide is in 1:1 ratio. And sodium hydroxide reach to the equivalency point when the volume is 25 cubic centimeters. Which means if they both have the same concentrations, if we assume same concentrations for sodium hydroxide and CH3COOH, then if they have same concentration, then they should have the same volume 25 cubic centimeters. Both should have 25 cubic centimeters to come to the equivalency point at point B. Therefore, we can say that here the volume of CH3COH here is 25 cubic centimeters. Right? So that's why I am taking it as 25 here. Volume is 25. Then I get the moles as these. Then now here the sodium hydroxide mole amount is less. So when we subtract this, remaining finally here 12.5 into 10 to the power minus 3 moles will be remaining. Here there will be no sodium hydroxide, and here C into 12.5 into 10 to the power minus 3 moles of CH3CO minus sodium plus will be formed. Here there is no. Right? Now if we find the concentrations of these two, right? Here this one has 25 cubic centimeters and here we put 12.5 cubic centimeters. So the concentrations will be 37.5 into 10 to the power minus 3. The volume is that. So which means what? Both CH3COH and CH3COO minus sodium plus are present in equal concentrations. Now this contains weak acid and conjugate base. Weak acid is CH3COH and conjugate base is what? CH3COO minus sodium plus. So this is a buffer solution. Right? Then we can write the Henderson equation to calculate the pH. So that is, I'll write it. I'll erase this one and write pH equals pKa plus log 10 conjugate base over weak acid. Right? So here the conjugate base and this is the conjugate base concentration. This is the weak acid concentration. So both of them are equal. Right? These two concentrations are equal. Therefore, pH is equal to pKa. Therefore, the first answer is correct. They are saying pH is equal to pKa. That is correct. At point A, the concentrations of the remaining weak acid and its conjugate base in the titration mixture are equal. So, again the same thing. Yes, the remaining weak acid concentration, that is remaining weak acid concentration and conjugate base concentrations are equal. Then at point B, the concentrations of H plus and OH minus in the titration mixture are. Here the pH at B is 11. Like it is in the middle of 10 and 12. No? So it is near to 11. So pH can't be 7. Right? If it is neutral, pH should be 7. Why I am saying it as neutral? Now, here they say concentrations of H plus and OH minus in the titration mixture are equal. So, if H plus and OH minus are equal, it should be a neutral solution, which means the pH should be 7. But if we see the pH at point B, it is like 11. Right? At B, pH is 11. So, the concentrations of H plus and OH minus are not equal. So, this is the wrong statement. Answer is 3. Let's see the other answers as well. Phenolphthalein can be used as an indicator for this titration. Yes, we can use phenolphthalein as an indicator because phenolphthalein show a color change in between 8 to 10. Right, approximately 8 to 10 it shows a color change. Therefore, here the rapid pH change is in between 8 to 12. Right, the rapid pH change, here the rapid pH change is from 8 to 12. So, we can use phenolphthalein as an indicator for this. So, the fourth is also correct. Fifth one, at point C, the pH of the titration mixture is lower than the pH of the sodium hydroxide solution used. What about that? Now at C, the pH is about 12. Right? Now the weak acid has finished and there is more sodium hydroxide being added. More amount of sodium hydroxide is being added, which means the pH is high there. Right? So from 25 to 40 cubic centimeters now. Here it is like 40 cubic centimeters now. More sodium hydroxide is added. Right? So that is lower than the pH of the titration mixture. At point C, the pH of the titration mixture is lower than the pH of the sodium hydroxide solution used. So, when we see this one, because the final OH minus concentration is what? Now, I'll erase this part. Now from 25 is the equivalency point now. From 25 to 40, more sodium hydroxide is there. Right? So the final OH minus concentration is what? C into 15 into 10 to the power minus 3 divided by 65 into 10 to the power minus 3. How do I get it? Because 40 minus 25 is the what? 40 minus 25 is the excess sodium hydroxide present. And this is the total volume. 40 plus 25. Right? So this is the final OH minus concentration. So the final OH minus, we are getting the final OH minus concentration as this. So the pH of the titration mixture is lower than the pH of the sodium hydroxide solution used. Right? So that is now here the final OH minus concentration is lower. Right? Final OH minus concentration is lower means pOH is high. Then pH plus pOH is a constant. Right? So if pOH is high, pH should be less. Therefore, pH of the titration mixture is lower than the pH of the sodium hydroxide solution. Why the final OH minus concentration is lower? Because the volume is high here. Right? There is a high here. The volume is high. Therefore, the OH minus concentration is lower. Therefore, pOH is high. When pOH is high, pH is lower. So, fifth statement is correct. So, the answer is 3 for the 12th MCQ. Right. Next, we'll move on to the 13th MCQ. An organic compound A gives a colored precipitate with 2,4-DNP when compound A is reacted. Now, A gives a colored precipitate with 2,4-DNP. Right? Now, when compound A is reacted with acidified potassium dichromate, compound B is formed. Now, when this is reacted with acidified potassium dichromate, compound B is formed. And B is formed, and when A is reacted with H plus potassium dichromate, compound B is formed. And the solution becomes green. Right? The compound B did not give a colored precipitate with 2,4-DNP, but this shows no reaction with 2,4-DNP. Now, what are the compounds which gives reactions with 2,4-DNP? Aldehydes and ketones undergo reactions with 2,4-DNP, which means B can't be an aldehyde or ketone. B can't be an aldehyde or ketone. B can't be an aldehyde or ketone. Right, when we go through the answers one by one, first let's see the first answer. Right, so A gives now they are asking the structure of A. What can be the structure of A? So organic compound A gives colored precipitate with 2,4-DNP. It means there should be aldehyde or ketone to give a colored precipitate with 2,4-DNP. Now this has ketone. So this can give a colored precipitate. Next we will see when compound A is reacted with potassium dichromate, compound B becomes green. So when we react H plus potassium dichromate now. So when we react with this, compound B is green. Now here it should have, here a ketone is present. Now ketone can give what? Ketone can give a secondary Now here this is a secondary alcohol. Then secondary alcohol can oxidize to form what? A ketone. Right? So that is also can form. Next compound B is formed, and now this is B. Compound B did not give a colored precipitate with 2,4-DNP. Now this is a secondary alcohol, and when secondary alcohol is oxidized in the presence of H plus potassium dichromate, it gives a ketone. Then ketone gives a colored precipitate with 2,4-DNP. Right? So as this gives a colored precipitate with 2,4-DNP, this can't be A. So first one is wrong. Next we'll go to the second answer. Right? So I'll erase this part. Now if we go to the second part, the second answer is like this now. CH3CO, CH2, 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 OH. Right? 1, 2, 3, 4. Another CH2 is there, right? And OH. Right. So again, A should give a colored precipitate with 2,4-DNP. Because of this ketone, it gives a colored precipitate with 2,4-DNP. Then when compound AV is reacted with acidified potassium dichromate, now what happens when this is reacted with acidified potassium dichromate? This is a primary alcohol. Then it gives what? Carboxylic acid. Right? It gives carboxylic acid. The compound B did not give a colored precipitate with 2,4-DNP. So what can you say about that? But here there is remaining CO. There is remaining CO. This ketone is there. So this ketone, it gives a colored precipitate with 2,4-DNP. Right? So second answer also can't be. Now let's see the third answer. Right? Third one, gives a colored precipitate with 2,4-DNP. Yes, because of this aldehyde group, it gives a colored precipitate with 2,4-DNP. Next, when it is reacted with potassium dichromate, this is a primary alcohol. So it forms what? COOH is formed. Right? Next, we'll see the compound B did not give a colored precipitate with 2,4-DNP. What can you say about it? Yes. Compound B does not give a colored precipitate with 2,4-DNP. Because here also COH is formed, here also COH is formed. So there is no one to give a colored precipitate with 2,4-DNP as there are no remaining aldehydes or ketones. So the answer should be the third answer. Right? Next, let's see what? Fourth answer. Organic compound A gives colored precipitate with 2,4-DNP. Yes, here it gives a colored precipitate with 2,4-DNP. Because here also there is an aldehyde. Now in the third answer, if I go for it again, here it contains an aldehyde. So this aldehyde is also turned to a COH. Right? Therefore, there is no remaining aldehydes or ketones. Therefore, it gives no colored precipitate with 2,4-DNP. That's why I chose the third answer as the correct answer here. Now, if I go for the fourth answer, right? Fourth answer, A gives a colored precipitate with 2,4-DNP. Yes, because of this aldehyde, it gives colored precipitate with 2,4-DNP. Now, we are reacting it with acidified potassium dichromate. Then this one gives what? CHO gives COOH when oxidized. You all know the aldehydes when oxidized, it gives COOH. Now here it contains CHOOH OH and CH3. When this is oxidized, it gives what? COCH3. A ketone is given. Now ketone is given. Now this is compound B. Now. So when B is reacted with 2,4-DNP, it gives a colored precipitate. Why? Because here a ketone is formed. Right? Now so therefore fourth is also not the answer. Now when we move on to the fifth one, again it gives a colored precipitate with 2,4-DNP. No, right? There is no one to give colored precipitate with 2,4-DNP here. There is no aldehydes or ketones. No, here there is an OH group. Here also there is an OH group. Therefore, there is no one to give a colored precipitate with 2,4-DNP. Right? Therefore, the answer is third one. Right. Now, let's move on to the 14th question. Next, the 14th question. The volume of 5 moles per dm cube H2SO4. H2SO4, 5 moles per dm cube. Required to react completely with 20 cubic centimeters of 30% sodium hydroxide. Sodium hydroxide 30%, 20 cubic centimeters. By mass and density 1.4 grams per cubic centimeter is. So they are asking how much volume of H2SO4 is required to react completely with 20 cubic centimeter 30% sodium hydroxide by mass and density 1.4 grams per cubic centimeter. First we will write the balanced equation for this. Right? H2SO4 plus sodium hydroxide, it gives sodium sulfate plus 2H2O. Here 2 sodium hydroxide is used. Right? Now the equation is balanced. Right. So here the ratio is what? 1 to 2. H2SO4 to sodium hydroxide ratio is 1 to 2, which means 2 moles of sodium hydroxide reacts with 1 mole of H2SO4. Right? Okay. Now let's see the number of moles of sodium hydroxide. Right? So this is 1.4 grams per cubic centimeter and 20 cubic centimeter is used. So we can find the mass of sodium hydroxide. How? By multiplying the density and volume. 1.4 grams per cubic centimeter times 20 cubic centimeter. It gives 1.4 times 10, 14 times 2. It gives 28 grams. Right? Then from this 28 grams, there is only 30%. When you simplify, you will get it as 8.4 grams. Next, we can calculate the number of moles of sodium hydroxide. In sodium hydroxide equal 8.4 grams divided by the molar mass of sodium hydroxide. So, sodium 23 plus 16 plus 1. It gives 40 grams per mole. Then the number of moles is 0.21 moles. Right? Which means how many sodium hydroxide has reacted? 0.21 moles. Right? Now we can find the moles of H2SO4. Now sodium H2SO4 to H2SO4, I'll write in top. H2SO4 to sodium hydroxide ratio is 1:2. Sodium hydroxide is 0.21 moles. Then how much for this? Divided by 2 now. 0.21 divided by 2, it gives 0.105 moles. Now they have given the concentration of H2SO4. Now you have to apply C equals N over V. Then they ask in the volume now. So V equals N over C. we know the number of moles of H2SO4. What is the number of moles of H2SO4? 0.105 moles. And the concentration is what? 5 moles per dm cube. So when you divide this, you will get the volume as 0.021 dm cube, which means 21 cubic centimeter. So the answer is 2. Answer is 2 for the 14th question. Right. Next, 15th MCQ. A closed rigid container at room temperature contains equal masses of helium and neon gases. Now it's better to sketch these data, right? Helium and neon, they are not reacting gases now, because they are inert gases, right? So they do not react with each other. So you have equal masses of these two. Then the total pressure of the container is P. Total pressure is P. The partial pressure of helium. Now, how can we find the partial pressure of helium? We should know the mole fraction of helium into the total pressure, right? So the total pressure is given and we need to find the mole fraction. If we find the mole fraction, then we can calculate the partial pressure. So we have to get the number of moles of helium and neon. So the number of moles of helium is, they are contained in equal masses now. So you all know N equals simple M over capital N. So M over molar mass of helium is 4. So this is the amount of moles of helium. Then number of moles of neon. Number of moles of neon is M over the molar mass is 20. So this is the number of moles of neon. Next we need to find the molar fraction of helium. So for that we have to divide the amount moles of helium with the total number of moles. So the moles of helium is M over 4 moles divided by the total number of moles, that is M over 4 plus M over 20 moles. So what is the answer you are getting here? M over 4 plus, you have to multiply this by 5 now. Then 5m plus m, 6m over 20. Then 4 times 1, 4 times 5, m to m cancel. So this is 1 divided by 6 over 5, which means 1 into 5 over 6. 5 over 6 is the answer, right? 5 over 6 is the answer. So this is the mole fraction. Then we found the mole fraction of helium as 5 over 6. Then the total pressure is P. So the answer is what? 5 over 6P, which is the second answer. So the answer is 2 for the 15th question. Next, 16th question. H2 gas plus I2 gas equilibrium reaction to HI. Above reaction is at equilibrium in a closed rigid container, right, at constant temperature. Which of the following correctly explain the change in the rates? The change in the rates of the forward and reverse reaction immediately after the addition of a certain quantity of I2 into the container. Now, if we add a certain quantity of I2 to the container, what is the immediate change that happened in the rates of forward and reverse? In the rates of forward reaction and reverse reaction. Right. Now, here, this is in an equilibrium now. So, we have to use the Le-Chatelier principle here. Now, if a certain quantity of I2 is added, what happened? The I2 concentration increases now. then the reaction tends in the forward direction. So the forward reaction rate increases. Why? In order to lower the I2 concentration. In order to lower the I2 concentration. Therefore, the answer is what? The answer is fourth answer. Answer is 4. The rate of the forward reaction increases. Yes, forward reaction increases. And the rate of the reverse reaction does not change. Right? Because they are asking the immediate change now. So, the immediate change is the forward reaction rate increases. So, the answer is 4 for the 16th question. Now, let's move on to the 17th question. A solution was prepared by mixing 100 cubic centimeter of 1mCH3COOH and 100 cubic centimeter of 1mCH3COO sodium. So both are mixed in equal volumes and equal concentrations, which means CH3COOH concentration and CH3COO sodium concentrations are equal, and this is a buffer solution. Why? Because it has a weak acid and conjugate base, right? pH is 4.8. Then when a few drops of 0.1 mHCl was added to this solution and mixed well, the pH still remained at 4.8. So pH has not changed. So which of the following reactions would have taken place to prevent the pH from changing? Now we are adding H plus now. H3O plus. Now H plus is added. So what happens for this H plus? This H plus is reacted with CH3COO minus. Because here it has CH3COO sodium. Now it gives CH3COO minus and sodium plus upon ionization. So this H plus is taken by CH3CO minus and it forms what? CH3COH. So this reaction is shown in answer 2, right? Not 1. No? Answer 2 is the correct answer because H plus with water it forms H3O plus. So it's okay. H3O plus CH3CO minus. This H plus is taken with CH3CO minus and CH3COOH is formed plus H2O. So the answer is 2. Right? Because this H plus is taken by CH3COO minus. So the pH does not change. Right? Right. Now let's move on to the 18th question. Which of the following represents the energy diagram of the reaction H2 plus Cl2 gas giving 2HCl gas? Bond energies of HH, Cl and HCl are right. So the bond dissociation energies are given, no? Right? So how can you find the enthalpy for this? Delta H equals sigma enthalpy of break-in bonds. Enthalpy of break-in bonds minus sigma enthalpy of forming bonds. Right, so what are the break-in bonds here? H2 bond is broken and Cl2 bond is broken. And there is only one H2 and here also there is only one Cl2. So for the HH bond break-in that is 430 and for the Cl-Cl bond it is 240. Minus what are the forming bonds? H and Cl bond is formed. Right, so and that energy is 430. Right, and there are two HCl bonds formed. So there are two HCl bonds formed, therefore we have to multiply it by 2. Right, 2 times 430. Then when you simplify this, you will get the answer as what? Minus 190 kilojoules per mole. So let's select the answer with 190. Here it has 190. Here also 190. Yeah, only these two. Then we have to select. Now this is minus 190. This minus means what? This is a exothermic reaction. So what is the correct energy profile for exothermic reaction? Fourth one. Right? These products should have less energy than the reactant's energy. So the answer is 4. Next we will move on to the 19th question. Consider the reactions given below. So in order to find the answer for this also, I will erase this part. Right. 19th question. Consider the reactions given below. The delta G values at temperature T are given. Right. So what is the reaction? This is the reaction. NH3 plus 2O2 gives HNO3 and H2O. So we have to form this reaction. What? NH3 plus 2O2 giving HNO3 plus H2O. Right? And we have to form this reaction from these 3 reactions. Right? Now how can we form this 1 NH3? Now here only this reaction, wait. Only this reaction has NH3. So and there is only 1 NH3. So if I label these reactions 1, 2 and 3, I have to divide the first equation by 4. So 1, when I divide it by 4, I can get NH3 plus 5 over 4 O2 plus O2 gives NO plus 6 over 4 means 3 over 2 H2O. Then I'll skip O2 a little and I'll go for the third one. Now I have to form, now NH3, 1 NH3 I get it. Now other one is O2. O2 is present in all these 3. Therefore I'll leave it for a while. Then I'll go for HNO3. I have to form 1 HNO3. So HNO3 is only present in this third one. So how can I get 1 HNO3 from that? By dividing the third equation by 4. So when I divide the third equation by 4, I can get NO2 plus O2, 1 over 4 O2 plus 1 over 2 H2O gives HNO3. Now I have formed NH3 and also HNO3. Right? Now I have formed 2 O2. Now here how many O2 are present? 5 over 4 plus 1 over 4. Now there is already 6 over 4, which means 3 over 2 O2 are present, which means 1.5 O2. If I form another 0.5 O2, I can get the 2 O2. Right? 0.5 means I have to get half O2. How can I get half from this? I have to divide this by 2. So I have to divide the second equation by 2. Then I am getting NO2 gives NO plus half O2. But this reaction should be in the other way, because here O2 is as a product. O2 should give as a reactant. So I have to get minus of this. So if this is minus, I can get it as this. Half O2 NO NO2. I am getting the minus reaction. Now I have to add these things. 1 divided by 4 plus 3 divided by 4 minus 2 divided by 2. First one, that is minus 1010 divided by 4 plus third one, that is minus 170 divided by 4 and minus 2 over 2. Minus second one is 70 over 2. Then the answer for this is what? Minus 1010 over 4, you are getting minus 252.5. Then minus 170 over 4, you are getting minus 42.5. Minus 70 over 2 is minus 35. So that is 1, 2, 3, 5, 10, 10, 13, 330 minus 330 kilojoules per mole. So the answer is 5. Answer is 5 for the 19th question. Right, now we will move on to the 20th question. Which of the given compounds will undergo all the 3 of these reactions 1, 2 and 3 given below? Reacts with PCl5 to give a chloro compound, undergoes a self-condensation in the presence of aqueous sodium hydroxide, undergoes a reduction reaction with lithium aluminium hydride. So you have to go one by one again. Reacts with PCl5, first one. This one reacts with PCl5 and gives Cl. Then undergoes self-condensation in the presence of aqueous sodium hydroxide. It should have an aldehyde or ketone, right? But you can't see an aldehyde or ketone in the first one, right? Therefore, it can't be the answer. Then undergoes a reduction reaction with lithium aluminium hydride. When it undergoes a reduction reaction with lithium aluminium hydride, this becomes CH2 NH2, right? But this is not the answer because it can't undergo a self-condensation reaction with aqueous sodium hydroxide. In order to now self-condensation reactions are given with aldehydes and ketones. But aldehydes and ketone present is not enough. This aldehyde and ketone should have an alpha carbon. And this alpha carbon should have an alpha hydrogen in order to give a condensation reaction. Even in ketones, right? And alpha hydrogen should be present. Alpha hydrogen should be present. Because this is the carbonyl carbon. This one and this one is the carbonyl carbon, and the adjacent carbon for carbonyl carbon is the alpha carbon, and the hydrogen bonded to that alpha carbon is called the alpha hydrogen. In order to do self-condensation reaction, alpha hydrogen should be present, right? Okay, now we'll move on to the second answer. Reacts with PCl5 to give a chloro compound. Yeah, here there's a secondary alcohol now. So it gives a chloro compound. Then undergoes a self-condensation in presence of aqueous sodium hydroxide. Here alpha hydrogen is present. So it can do self-condensation reaction as well. Undergoes a reduction reaction with lithium aluminium hydride. Yes, because this COH with lithium aluminium hydride. So I'll write it clearly. This COH with lithium aluminium hydride, it gives CH2OH. Therefore, primary alcohol is formed. Therefore, all these three are satisfied in the second answer. So, we can choose the second as the correct answer. Answer 2. So, we'll go through the others as well. Third one, reacts with PCl5 to give chloro compound. Here Cl is formed. Then undergoes self-condensation in presence of aqueous sodium hydroxide. No, it can't do a self-condensation here. Why? because it is now if I take this one, this COH will go down, right? This COH, this carbonyl carbon is bonded to benzene now. It has an alpha carbon here, but there is no alpha hydrogen here, right? Therefore, it can't do the self-condensation reaction. Then undergoes a reduction reaction with lithium aluminium hydride. Yes, it can, because here the aldehyde is present and it forms CH2OH with lithium aluminium hydride, right? Then fourth one, no, right? It can't give any reaction with PCl5. Then what about the self-condensation? Yeah, it can do self-condensation because alpha hydrogen is there now. Then lithium aluminium hydride reaction also it can do, because this is a ketone and it forms a COH. Here it forms a secondary alcohol with lithium aluminium hydride, right? Then fifth one, here this is a carboxylic acid, right? Carboxylic acid, so fifth one, there is reaction with PCl5, here Cl it gives, and undergo self-condensation. No, it can't undergo self-condensation because there is no aldehyde or ketone and there is no alpha hydrogen there, right? Therefore, no self-condensation. Then undergoes reduction reaction with lithium aluminium hydride. Yes, when this undergoes reduction reaction with lithium aluminium hydride, right, it gives what? This with the part with benzene one, right, it forms CH2OH, other things, right, plus this part, it also become an alcohol, CH3OH, right? Okay.